welcome back to StudyOnion. And today we're going to be talking about retrograde motion and elongation, conjunction, opposition, as well as what happens in the Zodiacal Band. Let's get started! Since the dawn of civilization, lots of different astronomers and people that used to look at the sky have noticed the changing positions of 5 points of light, which change in relation to the other stars. And these were later named by the ancient Greeks as wanderers, which in Greek was planets, from which we now use the word planet. The Greeks noticed that the motion of the planet was actually confined to a narrow band in the sky, which we named the Zodiacal Band, and that was roughly centered on the sun's motion and passed through at least 12 or more constellations. And this is actually explained by the fact that all planets orbit the sun in roughly the same place. So the bar chart on these slides show the orbital inclination of each of the planets in our night sky. And by definition, this actually means that the inclination of the Earth's orbit is 0, because the inclination of all of the other orbits is used in relative to the Earth. So the Earth is the base, and then everything else is measured from the base or the Earth. And the small values of orbital inclination, as we can see on these graphs, they don't really go much higher than 8, confine the planets to the narrow zodiacal band in the sky, which is centered on the ecliptic. Now, just so you know, orbital inclination is the angle between the plane of a planet's orbit and the plane of the Earth's orbit, or the ecliptic, around the sun. Tonight, the planets slowly move eastwards, but ancient astronomers actually noticed that occasionally they went backwards from east to west instead of west to east in a loop or a zigzag motion. And this motion that we can observe in the night sky is actually known as apparent retrograde motion. Look at the diagram on the slides. We can actually see that this is caused due to the varying speeds of the orbit of Mercury, Earth, and other superior planets, as well as inferior ones, in their orbit around the Sun. And this is what causes this retrograde motion. In the diagram, we can see a superior planet being shown at different intervals. And by looking at this diagram, we can actually explain retrograde motion in terms of the faster moving Earth overtaking the superior planet on the inside of its orbit. But this actually caused huge problems for astronomers back when they didn't truly understand retrograde motion. A little look at a video clip where retrograde motion is explained in slightly bit more detail, and you can see why that shape appears to be visible in the night sky. So let's take a little look at some definitions first. So a conjunction is when two objects are appearing close together in the night sky. So in terms of the diagrams here, a superior conjunction is when a planet passes behind the sun from our vantage point or our view on Earth. An inferior conjunction is the opposite, when the planet or object passes in front of the sun from our vantage point on the Earth. Now, opposition is when an object that orbits outside of the Earth's orbit, so superior objects, is when the object is opposite to the sun in the night sky. And finally, greatest or maximum elongation is when the position of a planet in which the Sun-Planet-Earth angle, so for example the Sun-Mercury-Earth angle, is 90 degrees or as close as it can possibly get to 90 degrees in the sky. So let's first take a look at an inferior planet, so that of Mercury or Venus. The picture here is of Mercury. The first thing is that an inferior planet such as Mercury is best observed when it appears farthest from the sun in the morning or in the evening sky, and this is at or close to the greatest elongation, when the angle of a sun, planet, Earth is at 90 degrees. When a planet or an object is at inferior conjunction, a planet may undergo a transit of the sun's disk. But transits are actually extremely rare events because the orbital inclinations of these planets make the planet go slightly above or below the sun's sky. A more common event is an occultation, in which a planet may temporarily obscure a further, so a distant star, moves in front of the star for a few moments. Take an example of a superior planet such as Saturn or Jupiter. A superior planet is best observed at or close to opposition. At this point in its orbit, the planet is closest to the Earth, at its brightest and opposite the sun in the sky. It is possible to observe the planet all night long and with the highest resolution. Let's just quickly talk about the apparent motion of the sun in the sky. Let's just leave the planets for now and look at the sun's eastward journey across the celestial sphere during 1 year. Of course, the sun isn't actually moving. Its apparent motion is actually due entirely to the orbital motion of the Earth and its constant 23.5 degree tilt of the Earth's equator in relation to the ecliptic. The position of the sun on March the 21st marks the zero of right ascension at the first point of Aries, denoted by the Y sign or the symbol for Aries, which you can find on this diagram on the March section. This graph shows the celestial coordinates of the sun over a course of a year. The two signs of Libra on either sides of September denote the first point of Libra, where the sun returns to the southern hemisphere on September the 23rd. So, to summarise, the motions of the planets was confined and is still confined to a narrow zodiacal band that was centred roughly on the sun's motion and passes through 12 or more constellations. And this is actually all explained by the fact that all the planets orbit the sun in roughly the same plane. Night to night, planets move slowly eastwards, but ancient astronomers noticed that sometimes the planets move backwards in a zigzag motion, and this is known as apparent retrograde motion and happens to the varying speeds of the planets in their orbits around the sun. Let's look at some definitions. Superior conjunction is when a planet passes behind the sun from our vantage point on the Earth. Inferior conjunction is when a planet passes in front of the sun from our vantage point on the Earth. An object that orbits outside the Earth's orbit passes through opposition. This means that the object is opposite our sun in the sky. Finally, greatest or maximum elongation is when the position of the planet is where the sun-planet-Earth angle is 90 degrees or as close to 90 degrees as possible. Transits are when a planet passes through the plane of the sun in the sky, but are actually extremely rare due to orbital inclinations of inferior planets. Occultations, where a planet may temporarily obscure a distant star as it moves in front of the sun, are much more common. Finally, the Sun's apparent motion is due entirely to the orbital motion of the Earth around the Sun and the constant 23.5-degree tilt of the Earth's equator to the ecliptic. Hopefully that helped you learn more about observing the solar system. Thank you very much for watching, and I'll see you next time with a new video. But for now, bye!